And hello again, and welcome to episode 14 of the Computercraft tutorials. So last episode we left off and we finished our go-to function, which allows us to have the turtle go to any location on the map if you give it the coordinates and give it the right starting coordinates. And I think we're ready to start actually writing the Quarry program, or the part of the program that does the quarrying. So let's start doing that. Edit Quarry. Right. So the way I'm sort of imagining this working is I'm going to use the go-to function to tell the turtle where to start, like what its starting position is going to be for the quarry, and from there it's going to run a quarry program. And I'm going to not be using the go-to function in that quarry program, I think. For reasons we'll see later. But what I'm imagining right now is having a couple of functions that sort of split up the quarrying process into little chunks. So the top layer would be, or let's say the bottom layer would be sort of like run or dig a quarry, and that's sort of very abstract way of doing it. If you look above that, you could split it up into layer by layer. So the function could be dig layer, for example. That would be a function. Now you could even split up dig layer into dig line, which would be one line in, an entire 2D layer. I think that's as far as we can split that up pretty much. I'm going to start with the dig line function, which is going to be one line in a layer of the quarry. So, and that's going to be really simple. It's going to be dig line. Oop. There we go. And all this is going to be is we're going to be having a for loop, and it's going to dig for a certain distance, which is going to be called line length for now, and we can determine what line length is going to be in a minute. And all we'll be doing is move forward. That's it, you dug one line. Now line length, we'll define it at the top here. Let's see. Oh, I haven't got that many variables at the moment, it's fine. So line length, I think for the moment I'm going to go for like a 10 by 10 quarry, so I'll make it 10. And then while we're here, might as well define the number of lines. So we're going to do 10 lines in a layer. So the length of lines is 10, and the number of lines we're going to do is also 10. So we'll have a nice little 10 by 10 quarry. So there's dig line. I might need to expand that later, I'm not quite sure yet. Can't remember how I did certain things the previous time that I wrote this. So now we're going to have dig layer, which is going to do dig line a couple of times until it's finished the layer. So it's also going to be a for loop with I is equal to 1 until lines, we called it. It's the number of lines it's going to do. It's going to do something for that amount of time. Right, so whatever's going to happen, we're going to have to dig a line a couple of times. Now the only issue is that we have to turn around and stuff, because we're going to be going forward and we'll be at the end of the quarry, or the other end of the quarry, and then we have to turn around, move one block to the left or the right, depending which direction we're going, and go all the way back again, so that we're not just going in one long straight line, which is what would happen at the moment. So I'm just going to have to think about how we're going to do that in a minute. So it's got to do with the direction we're looking in. Now let's say that we're going to have to sort of make a rule here about how we dig our quarries. So let's say that we start our quarry right here, for example. Now we could take as a rule that whenever we start a quarry, we always start going north. So we go 10 blocks to the north. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'd end up here. And then we move to the left, and we go on to the left, move to the left again, and then go 10 blocks again. And then all of a sudden we have to move to the right and forward, and then to the right again. So we have to kind of keep track of how many times we've done this to know which direction we have to move. Now luckily with a for loop we know exactly how many times we've done it, because we have I, which is the number of times we're doing it. So what we could say is whenever we're at an uneven number, so when I is 1, this is the first time we do it, we do 10 blocks, and then we have to turn left and go forward, and then left, and then I will be 2 now because we're digging our second line, so we've got an even number all of a sudden. So whenever I is an even number, we have to turn right, and then forward, and then right again, and we'll be 3 and we'll be back on an odd number again, and we can turn left. So I think that's probably a decent way to go now. So I think that'll work. Just thinking if I'm forgetting anything here. Let's just try that, see how it goes. So we're digging a line. That's good. After we've dug the line, so we need to check if I... Now here's how you check whether something's an odd number or an even number. You do modulo 2, and if you remember from quite a couple of episodes ago when we talked about arrays, it probably was. Actually no, it was the first episode of this, I don't know, we talked about it at some point. But the modulo gives the remainder of a division, so you get the remainder of I divided by 2. So the first time, 1 divided by 2, you know 2 doesn't fit in 1 at all, so your remainder is 1. So, and that's the same for 3 as well. So 3 divided by 2 is also 1, because 2 fits in 3 once, and your remainder is 1. So if that is equal to 1, then... Oops, come on. Need a space there, then. Then we're going to do a left. Yep, that's right. And a move forward, so that we're on the next line. Now I have to move left one more time, and we'll be looking in the correct direction again. And that's it. So that's our turn left, or at least that's our what we do when we're on an odd number. And if we're not on an odd number, so you can just go else. I think you just do else. I don't do else that often in Lua, so I'm not quite sure if I got the syntax right here. But regardless, we'll try it. And if it moans at me, then I'll have to look it up. Move forward. So this is exactly the same, except we're turning the other way. We'll end that. Yeah, you don't have to do the end for the if you do an else, so you can just do else and then it will... Don't have to do the end, basically. So that will bring us to the next line, and then it does dig line again, and we go 10 forward. Perfect. Now considering we're already starting on square number 1, we only have to dig forward 9 times, we want 10 by 10, so I'll make this 9, or at least the line length. Because we're already starting on place number 1, so we have to dig forward 9 times to actually have dug 10 spaces, but that's just details, doesn't really matter. Okay, so that is dig layer. So after we've dug a layer, we need to go back to the starting point, I guess. So let's make another function, called dig quarry. And that. So for, or maybe I should do while. So we're going to have to determine how deep we want the quarry. We can either, give the quarry a certain depth, or what we can do is just say something like we want to dig to a certain y coordinate, and then we're done. So what I like to do is just go while your y coordinate. Actually, I should do this differently. The lowest y coordinate you've had. We're going to create a new variable that keeps track of what the lowest y coordinate was. And once you hit, let's say y is lower than 7, I think that's safe, do, and I'm doing this completely wrong. So this is when we want to stop. So while your y min is larger than 7, so while you've never been at y7 or lower, or y6, let's say, you're going to keep doing this. So you're going to keep doing dig layer. Okay. Now before we do the quarry, we're going to have to do a go to, and then we're going to get a target, I guess, which is going to be x quarry, z quarry, and y quarry. Yep. So that's where you start off, and then you just start digging basically, and you keep digging layers until you're under y7, and once you're done with that, you can y min is equal to, let's put it up to 999. Actually, no, let's not do this here, to be honest. I'm just going to have to think. So what happens when you reach y6? So you finish your quarry, you're at y6, then what? You have to go home, I guess. Oh yeah, here we go. We just go back to the x quarry, z quarry, and y quarry. I think that would be a good thing to do. So you go back to where you started, and then we can reset the minimum y again, because we won't be at y6 anymore, is equal to 999, and it will reset it next time you move. Because the way I'm going to keep track of the y minimum is by the, let's see, the move down function. So you see, whenever you move down, there's a chance of you going lower than you had ever gone before. So at the end of the move down function, what we're going to do is going to say if your y minimum is smaller than your y coordinate, then your y minimum is equal to your y coordinate. So as soon as you hit a y coordinate that is smaller than your actual y minimum you had registered, oh, I should do this differently, bigger than, there you go. Then you're gonna, you've got a new minimum and you can set it. And that can only really happen when you go down. I mean, you could check it when you're going up, but it doesn't really make much sense, because you've already hit the minimum. So that's that. I have to create y minimum. I guess I haven't created it yet. Define y minimum at the top here somewhere. Put it here. So y min is equal to, I don't know, y coord, I guess. It's fine. Yeah, let me just explain that, I guess, because we've already defined y coordinate at the top here. So you can use that here to also set your y minimum, because it already exists. So that's fine. So I think, in theory, this should actually work now. Let me just check it one time. Right, so we've got a dig line, So for a certain line length, we're going to be moving forward. That's all that dig line does. Then we've got dig layer, which does dig line for a certain number of lines, and then it turns the correct way depending on how many lines it's done. So every other line it will turn the other way. And then we have dig quarry, which digs a certain number of layers until it reaches Y6, and then it stops and goes back to the start. Okay, awesome. So instead of go to, actually I could just use these coordinates, couldn't I? We're going to go dig quarry. Let me just get some other coordinates actually. So what we'll do is we'll start right here. This was the one I wanted. So this is x minus 171, z 208, and y is, let's say, 73. I'm just going to help out a bit here and clear some of this so we have a flat starting area. With sand, it's quite important to have a flat starting area because sand falls down if you dig under it, and it might mess up the turtle. That's something that I should improve in the move forward function, is it should keep checking if there's actually still stuff in front of it, and keep digging until there's no more stuff in front of it, and then you could also dig through sand without any trouble. But yeah, that'll come later. So I had minus 171, z 208, and y 73. Okay, we'll save it, exit, and let's see if this works. Oh, attempt to compare, blah blah blah. 75. It might be that is equal to that I did. I'm not sure. I wonder whether it's this. Do I need to put? That's interesting. I'm wondering whether I should be putting brackets around the if statements, or in the if statements. I don't think I have to. For some reason I just can't get used to the whole Lua syntax. Beg my pardon while I dick around. I'm going to go and look for 75 and then I'll see which line it is, but that's such a disadvantage that this thing doesn't have line numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Two more times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So it's here. This while apparently isn't like that. Oh, white target. Did I misspell that maybe? Oh. Yep. Wait a minute, no, that's correct. What's going on here? Go to function, go to white target. Ah. Oh, yeah, this doesn't exist, of course. Right, so I'm going to make this X quarry, Z quarry, and Y quarry. No, that's not right. No, this is the function definition. No, that's fine. I don't know. This shouldn't be moaning about this. That's interesting. Okay, I'm gonna have to try not make mistakes like that here. This is Z target. Come on. Oh, how I love debugging. So much fun. So apparently it doesn't like that, for no apparent reason. Have an end there. So yeah, I have the feeling that it's this if statement here, if I modulo 2 is equal to 1. But I can't see why it would be. Attempt to compare, blah blah blah, on nil and number. Yeah, so there's something not defined, something. Oh, is it the move down? See, it says line 75, which is when it does the move down there. But it probably means the actual move down function. I might not have defined y minimum, but I know I did, so... y min is equal to y chord. Yep, I don't really see the problem here. So I defined y minimum over here. That should be okay. I guess just for shits and giggles, I'll make this a number. God. Alright. Still. Oh well. That wasn't the problem. This is going to be one of those most boring episodes you've ever seen. See, the weird thing is that this is going in the go-to function as well, which was working yesterday. And now all of a sudden it's decided to give me errors, so... it's very peculiar. Am I missing a bracket here or something stupid? No. So it says I'm comparing something to nil value. So that means that something hasn't been defined. I don't understand why it's giving it here though. I'm going to accidentally, like, I don't know, remove y coordinate or something. No, it's still up there. You know what? Screw it. I'm going to end the video here. I think the idea is pretty clear. I'll make another video once I've solved this stuff and I can give the demonstration. For now, thanks for watching. I hope this wasn't too boring at the end. That's fine. So, yeah, thanks for watching, and I'll see you next video when I fix this, this stupid error. God damn it.